Okay, so now we're in the iBook part. So now we're going to throw all three angle bisectors together in a triangle and see what happens. All right. So they're all going to intersect, and again, it's called a point of concurrency. It's called the point of concurrency, and this particular one's called an incenter of a triangle. And I really like the name incenter. Why do I like that name? I'll tell you in a little bit. So we're going to use the expiration in the blue box. All right, I'm already there. So all these black lines are angle bisectors. Notice how like angle A, it's being bisected 43.4 is both sides. You can double that to get the total side. C is being bisected 31 and 31, so that was a 62-degree angle. Angle B is 15.6 on both sides. So the black lines from each angle is an angle bisector. All right, it's cutting the angles in half. The intersection of all three angle bisectors is, I just said this word, it's a point of concurrency. All right, the point of concurrency in this case is called an incenter. All right, so just to show you that I'm not pulling your chain, look, I can make any kind of triangle I want. They're always going to intersect. Oops, I made a straight line there for a second. Always going to intersect. I can't get the lines to not intersect. Pretty crazy that any triangle that has existed or that will exist in the future, all three angle bisectors will intersect at one point. All right, now we're going to drop down perpendicular segments. So I just tap that button. Now from point I, these green segments, they're all perpendicular to the side of the triangle. All right. Also, hold on, I forgot to mention this. Can the incenter lie outside of the triangle? Can it lie on the side of a triangle? The answer is no. It's always inside. Forgot to mention that part. It's always inside, and that's why I like the name incenter. An incenter is always inside the triangle. The angle bisectors will always intersect inside the triangle. And if you think about it, that kind of makes sense. That all angle bisectors would have to stay inside the triangle. They're coming from the angles, they're kind of pointed at each other. That's how I kind of like to remember it. Now I'm going to drop down the angle or the perpendicular segments from point I. So all of these green segments are perpendicular, and they're also all congruent. All right, tap the circle tool. So hold on, getting a little excited. IG, IJ, and IH, they're all congruent, so they all have the same length. Let me redraw that congruent thing. All right, now this one takes a little skill, but this is going to be pretty cool. All right, I'm going to make a circle, tap I, and then wow, there we go. And oops, undo, no. All right, no, it's only for that particular one. All right, we'd have to make a new circle each time, but this circle centered at I touches all three sides. That's pretty cool. All right, zooming in a little bit, bring it out maybe just a hair. All right, this circle centered at I, it's going to pass through G, J, and H. All right, they all lie on this circle, and this is called an N circle. An N circle or an inscribed circle. That's pretty cool. All right, and a little fun fact, if you want to draw a circle inside of a triangle, this is the largest circle you could draw. You can't draw anything bigger than this. All right, and what's so great about this, point I, the incenter is equidistant from the three sides. So the circumcenter's equidistant from three vertices, the three angles. I is equidistant to the sides. So they all have their usefulness. Like if you wanted to make something equal distance from 3 roads. Again, I was talking about shopping malls. If you have like 3 major highways, whatever, that's where you could put a shopping mall, a hospital, a high school, anything. All right. So then we just got these follow-up questions. They're just kind of the same thing. They're piggybacking off of all of it. The point of concurrency of 3 angle bisectors of a triangle is called the end center. The end center is always located inside. It has to be inside. The end center is equal in shortest distance to each side of a triangle. The end center is the center of a circle that is inscribed. All right, and how are they similar? They're a point of concurrency. So that means 3 lines are intersecting to form them. And they're both equidistant to something. All right, how is the end center different from the circumcenter? End center is formed by angle bisectors. It's always inside the triangle. The circumcenter is formed by perpendicular bisectors. And it can be anywhere. If you can recall from the other guided notes, they can be inside, outside, on a side, so on and so forth. All right, and let's just undo all this stuff. Let's just run through one more triangle. Let's make a pretty... All right, that's a pretty obtuse triangle. Again, we're going to drop down the perpendicular segments, make a center, and just to show you that the end center is always inside, and that's the largest circle you could draw in that obtuse triangle right there. Again, you can go to page 43 of your iBook, play around with this, have some fun. This is intense geometry. I love this stuff. Interesting. Blows my mind a little bit. Hopefully the same with you.